Hi everyone, and welcome back to video number 2 in our Unity tutorial series, creating a 3D space shooter. In this tutorial we promise to create an infinite star field around our camera and player object, and so this will help give us depth and a sense of speed as we fly around and through the galaxy. Basically think of it as that common visual effect that you would see in movies and games and stuff like that, where the stars fly by or move around the player. We're going to set it up to where it's really optimized, and the particles are created only in a radius around the player, and they disappear and appear only at a certain radius that you set in front of and behind the player. But from the vantage point of the player's camera, it will look like this star field goes on infinitely. So on our script folder here, let's right click, create C#, and let's call it star field. Okay? Now before we start our script, let's go back over here to the camera, and we want to go game object, create particle system. And there we go. Let's drag it into the player camera so it's child of the camera. And then let's click this little gear and reset the position so it's centered on the camera. We can turn off looping, we can turn off play and awake, we can turn off emission and shape. The only things we want to set is we want to simulate this in the world, and the scaling mode is shape. Alright, as for the material, default particle will work for our purposes. It's just a little dot. If you want to create a different material with a little star looking texture on it and drag it in here, you can. We're just going to use the dot. The reason we're not setting anything on this is because the script is going to completely control this particle system. So let's call it something original. Star field. That's not original. And let's left mouse drag the script onto it and double click it to open it up. We now have our star field script on the particle system. So in the last video we described hold on, let me zoom in here real quick. For our elderly viewers, no, I'm kidding. So we described up here, right underneath your class, usually the very first thing that you put in here are your variables, which are containers or slots to grab hold of data or information or components like rigid bodies, transforms, lights, you name it. So the first one we're going to use is private transform, and this transform. This might look familiar from the last video. This is simply a privatized, which means it does not show in the inspector, transform component that we're just going to have the script grab access to on its own. So that's why we privatize it, because we don't need to access this in the inspector. The next one will be a type of particle system, and actually in this particle system we're going to say particle, and we're going to grab the array of particles that make up this particle system, and we're going to call it points. We could call it something like stars or something like that, but I found sometimes keeping the variable name generic helps us be able to reuse the script. I.e., for example, I've used this same code for a star field to make dust particles in a survival horror game where you're walking through a house and the dust would kind of ambiently float in the house around you. And so I decided to just call them points. But they really represent all of the available particles, and this is a symbol for an array. You can Google array in Unity's documentation. It represents all of the particles in this particle system. So the next one will be a private variable as well, and it'll be a float. We described before that float is a floating point number, a decimal floating point, so it can be 0.001, 1.22. It is not an integer or an int or a whole number, which is 1, 2, 12, 24, or anything like that. So private float, star distance squared, private float. And this brings to mind another thing too, is I like to keep all of my private variables all kind of grouped together, ones that we won't be modifying or changing in the inspector. Star clip distance squared. And then down, after we've declared all of our private ones, which we're done with, we'll now go on to declare our public ones, and we will go public color, and call this star color. We will go public int, and we'll call it stars max, and we'll say that's equal to 600. Another public float, so it will show in the inspector, star size. So if you're seeing a common theme here, all the public ones are ones we're going to want to tweak values in the inspector. From trial and error, I discovered that 0.35 was a pretty nice size to start out with for my stars. You might find a different size that you like for your own taste. 60F, star distance. And then the last variable we need to declare here is public float star clip distance, and we'll say clip it 15 units out. So star color, I'm going to hit Control S, save, get rid of this silly error, and you'll see the private variables not show and the public ones show. So as you can see, star color allows us to go in here and just set any kind of color for our stars. Okay, so we'll just leave it this ridiculous silly purple or teal color. Stars max is whole numbers. It lets us set the amount of stars. Star size is how big the stars are going to be. Star distance is how far out away from the player are we going to draw particle stars. And star clip distance is where are we going to start clipping them off between the player and the camera, where they basically look like they disappear into the camera. Okay, so here's our start method or start function again, and this is run when the scene starts and you hit play. So we want to run some things in this start that we don't want to run every single frame, but we only want to do when the scene first starts up, and that is grabbing access to some components that we only need to grab access to once. And this transform component is one that's called caching components. It's pretty good optimization to do. Star distance square equals star distance times star distance, and so we're squaring that. We're going to multiply it times itself. Star clip distance squared. Autocomplete will make your life faster. It'll make things faster for you. Star clip distance times star clip distance. So what we're doing here in starter, we're just saying the star distance squared, that we don't actually change these values, the code does. We're just going to square off star distance. And star distance is one of the ones you set. So we're allowing the script to manipulate the data you set and give us another value on that. And the same thing is happening with the clipping distance. We're squaring that off as well. It's just a performance optimization too, and mathematically better off. Okay, so the first thing we want to do here is another method in here, private void, and this is going to be our create stars function, and this is what's actually going to create the star objects, or you can think of them as particles if you want. So the particles, or what we called points, we're going to go new particle system particle array, and inside of that array we're going to tell it the amount of particles you're going to have are going to be stars max, and that's this integer up here. We said 600. Now this allows us in the create stars function here, our method, to basically say this is the amount of particles, 600. It's almost identical to doing this, except if we were to do this, this value could never be changed from 600 unless you went into this code every time and changed it. This way you have a public variable in the inspector that you can change and tweak to your heart's content, and it updates in the function. So points, the next thing we're going to do is a for loop. And I'm going to write some of this out and then we'll explain a for loop. And we'll do it quickly. Time is of the essence, right? I plus plus. And then we'll put some brackets so we can execute what's inside of the loop. So inside of this loop we say points I dot position equals random inside unit sphere times star distance plus this transform. I wish it would spell correct too, like my cell phone. But that's being a lazy programmer, isn't it? And then points I color equals new. I think I hit the Windows key there for a split second. New color, and then color.r, color.red, green. Oops. Color.red, green, blue, and then color.a. Now, what's happened here is the autocomplete has went crazy. Red, green, color, alpha. And that's what it should look like. Oh, it's star color. I'm sorry. I'm going to copy that with Control-C. This is a very handy thing to do here. And what we're saying here, okay, so this is the one last thing in here, and then we'll explain this for loop. Points I dot size. So we've tweaked the position, the color, and the size. And the last one is we just want it to be star size. Okay, so what's going on here is this is a for loop, and it loops through some data, and it says let's create a temporary integer. It's equal to 0 as long as that integer is less than max stars, which in our case is 600. Add 1. Plus plus is pretty much the same as plus 1. All right, plus just adds 1 to it, but it will only continue to do that as long as this integer is less than max stars. Once this hits 600, it'll stop looping through this. So what that tells you is this for loop will loop through all the available stars that we have, and it'll stop once it's done that. Then we can say each one of these particles points, each individual one, which is I. The integer I here in this loop that it's looping through the max stars actually becomes a representation of each particle point. And so we say that one point in the loop, its position is equal to random inside unit sphere. And you can literally select this, copy it, and put it into Google, and I'm not going to do that right now, and look it up, but it just returns a random position inside of a sphere in Unity. And then we're going to multiply that position times the star distance, how far away you want them to be, plus this transform's position. So what's happening here is each individual particle, or what we're calling point, in this for loop is being assigned a position, a unique random one. And the same thing's happening to the color. Each particle or point is getting a new color here based on the star color we set. Star color R is star color red channel, green channel, blue channel, and even the alpha. And then we take each point or each particle and we say its size is equal to star size. That finishes our create stars method. Now all we need to do at this point is call that method, which means let's make it run. By default, just writing it in here, it won't run. We need to actually call this and make sure that it runs. So what we're going to do is we're going to make it run an update, which is every single frame of our game as it's running. And since the stars are going to move and fly around in outer space, we do want this to run every frame of the game. So we're going to ask a question like we did in the last script. And we're going to say if the points are equal to null, instead of returning an update, which nothing would happen because they're going to start out null, we're going to create stars. Pretty cool, right? So basically we're saying here, if the scene starts up and it's running and there are no particles or points, which there won't be, create them. And then it runs up here and it runs this method. Okay? So now we have to loop through. If the particles aren't null and they do exist in the scene and they're doing their deal, this create stars creates our initial set of stars that we need to manipulate. And then once they're not null, which means they're filled out with stars, we need another for loop because we're going to actually do, and you know what I'm going to do? I'm going to copy and paste this one because you know what? It just saves us time. We're going to create some brackets because everything we want to execute is going to be inside some brackets. So we're going to say in here, yes, create that temporary I integer variable, count through all the max stars, add 1 if we're not at max stars yet, and then do something in here. So we're going to say if points I, each one of those individual points, and I can't even spell position, if its position is less than this transform position square magnitude is greater than star distance square, then do something. Okay, let's go up in here in the brackets we made. And then we want to say, okay, if that's the case, then take that single point, take its position actually, dot position, and then let's do that random inside unit sphere again, except this time let's normalize it. Normalized times star distance. We'll explain some things in here in a moment when I'm done typing this, and you guys are probably typing along. Okay, and then we'll close that out and put a little bracket in there. So what we're saying in here is we're looping through. We're saying if the point's position is less than the position of this transform, the camera, basically, its square magnitude, but it's greater than the star distance squared, then yes, move these points around, give it a random position. Alright, so now we want to do what the next case would be. If points, I'm scratching my eye, if the position is less than this transform dot position, and I keep typing it that way, this position square magnitude returns the squared length of this vector. So it squares the vector positions. What do we have here? This square magnitude is less than or equal to the star clip distance squared. Then we want to do something. And so these are the stars. This is when they're being clipped. So what we want to do as they're clipping in and out between the player and the camera. So we'll need a percentage. So we're going to create a variable in here called percentage, and the percentage is going to let us get a floating point variable number that's going to be a percentage to 100% to 0%. That's going to allow us to adjust the alpha opacity and the size of it. So you can see why we sort of need a percentage for that. So the percentage is going to be equal to the point's position, the position minus this transformed position, and we're going to square its magnitude again, and then we're going to divide it by the star clip distance squared. Okay. So there's our position, or our percentage, and we're getting that because we're dividing by the star clip distance squared. And this update method or function here will use this percentage variable to tweak what we're going to type in here right now, which will be points I.color. So we're going to adjust the color of each new particle, and we're going to say the new particle is equal to 1, 1, 1, and then percentage. And so you can see here that the new color, RGB alpha, this is going to tweak the alpha. Alright? So that'll help fade the star in and out. Okay, so the next thing we want to do is scale its size as well. So points I, and we'll go size equals percentage percentage, and then by star size, because we also want to give you the ability to set basically a starting size that you want all of your stars to be. And then down here we'll go a couple brackets down. We want to get component, and we want to actually set this. So let's grab the particle system. We have the component. Let's grab one of the aspects of the component, which would be the ability to set particles, which would be the amount, and we're going to set it to points, and points dot length, so the length of the array. Basically, we're telling the particle system you're going to have this many points or particles that we've already established in the script. So there it is. The script is done. There's the last update function right here. I'll scroll up just a little bit. There's our create stars method. And then there's the start function right there. I'm going to hit Control S and save it. And hopefully we don't have any compiler errors, and we do. I typed something wrong. So I'm going to double click it. Hopefully will bring me to the line. And I see exactly what I did wrong. So I think I was supposed to put this one part here inside of brackets. No, that was it. Just removing the incorrect semicolon off there. So with all of these values set and our star field object in there with the script applied and then the player's camera, we'll hit play, and they might be a little difficult to see. I'm going to see if we can. Alright, so we can't tweak them during runtime because they're not running an update. Let's see if bright green works. Alright, so there they are, and you get a nice unique different scaling size, and some of them are alphaed out, and some of them look white, and some of them look like your green star color, and it gives you a lot of variety. And so the real beneficial thing here is as you move the player through, wait a minute, the player camera should be following. Okay. So as we move it, you can see our stars are, I don't know if you can see that in the editor. I may have picked a really bad color for the stars. Maybe it's just the size. Let me set them to 1 and you'll be able to see them much better. There we go. So as I move the player, you can see how optimally these stars only appear around the player, but they look infinite to the camera there. Pretty cool, huh? So they look like they're clipping in a little bit, and so that's where we can go in and tweak values. So let's have them clip away a little closer, a lower value, and let's double their distance so they're out further. And then we get quite a bit further distance, and then we don't really see them popping in as much, right? Let me see what the density is too of these. I think 600 or 800 is fine. And then I'm going to go back and make them 0.35, and I'm going to try to make them a really neat, cool purplish color. You can go in here and tweak the values. And I don't even see the purple because the skybox is purple. Alright. Let's try this. I can't hardly see those either. I'm just choosing horrible colors. Let's do this weird, crazy teal. Yeah, they show up better. Alright. Those look pretty cool. And they look cool when you rotate around. Give a lot of depth. They glow. It's pretty cool. So I'm going to cut the video off here because we're already at almost 25 minutes. That is how you create the infinite star field around the player. And it's optimized, obviously, because it just keeps the stars only around the player, and you don't fill your entire Unity scene with stars. And the next tutorial, we're going to set up our player control script, and we're going to drop in that proxy spaceship, and this way we don't have to watch me dragging a sphere around in the scene, and we'll have something a little bit more realistic to play around with in there. Alright, so looking forward to seeing you guys in the next video. I'm going to hit apply and establish that as a prefab connection, and I'll see you guys in the next video setting up the player script.